So in the previous class we discussed some few previous year GATE 2023 mechanical 1 mark question. In this class we discuss the new one. So the question is, consider a counterflow heat exchanger with inlet temperature of the two fluid 1 and 2 being T1 in inlet temperature of first fluid is 300 Kelvin and T2 in 350 Kelvin. The heat capacity rate of the two fluid are C1 is equal to 1000 watt per Kelvin and C2 is equal to 400 watt per Kelvin, and the effectiveness of heat exchanger given 0.5. Then we have to find the actual heat transfer rate in kilowatt. So the given data is counterflow heat exchanger. So draw the diagram. So first fluid this is 1 and second fluid this is 2. So the inlet temperature T1 in given 300 Kelvin and second T2 what is inlet temperature is 350 Kelvin. Let us interchange is due to temperature T2 is higher, so this is T2 in and this is T1 in. And effectiveness given 0.5 data from data, and C1 and C2 are given 1000 and C2 is 400 and C2 is C minimum. So we know effectiveness is Q actual divided by Q maximum, and we have to find Q actual, and Q maximum is C min into T2 minus T1 in. So Q1 divided by effectiveness given 0.5 and C min, that means C2, that is 400 into T2 350 minus 300. So QA into 400, 350 minus 300 is 50. So 5 by 10 into 400 to 50 is equal to Q actual, and then cancel. So 5 into 400 into 5, that is 10. Equal to Q1. Which is equal to 10 kilowatt. It is option B, the correct answer. Next question. A cylindrical rod of length h and diameter d placed inside a cube enclosure of side length L. S denotes the inner surface of the cube. Then the view factor F(S2)S is options are 0, 1 and let's solve the question. This is the cube of length L, and here is the cylindrical rod is present, which length is given H and diameter is D. So we have to find surface area of rod, which is equal to pi dh plus, this is pi dh, the outer surface area, and this the end and front side, which is equal to 2 times of pi by 4 d square. So this is the taken as A1, as we take this is first body and this is second. So A1 is equal to, let common pi dh plus d square by 2. So next, found the surface area of cube, which is equal to A2 is equal to 6 times L square. We know for cylinder F121 is equal to 0. So F11 plus F12 is equal to 1. So F11 is equal to 0. That implies F12 is equal to 1. This is equation 1. For cube, F21 plus F22 is equal to 1. We have to found Fs2s, that means F222 is equal to, so F22 is equal to 1 minus F21. So the B factor F21 is equal to, by reciprocal theorem, A2 F21 is equal to A1 F12. So F21 is equal to A1 by A2 F12. A1 given pi into dh plus d square by 2 divided by a square is equal to 6 L square. F12 given 1. This is equation 2. By putting equation 2 in 1, F22 is equal to 1 minus y dh plus d square by 2 divided by 6 L square. which is option D is correct answer. Next question is CNC machine has one of its linear positioning axis as shown in the figure, consisting of a motor rotating a lead screw which turn, move a nut horizontally on which table is mounted. The motor moves in discrete rotational step of 50 steps per revolution. The pitch of the screw is 5 mm and the total horizontal travel length of the table is 100 mm. Then what is the total number of controllable location at which table can be positioned on this axis? This is the figure. This is the motor and this is the screw and this is nut and this is table. So the given data is 50 step per revolution. That means the number of revolution is equal to 150 revolution per step. And the pitch is 5 mm. Just a minute. So the data is revolution of motor is one step is equal to 1 by 50 revolution per step, and given pitch of the lead screw is equal to 5 mm. So the movement table length is given 100 mm, which is equal to 150 revolution per step, and we have to found number of step, and the lead screw, that means pitch length is 5 mm. By unit balance, number of step cancelled out, and number of step per revolution, and the revolution cancel, and finally we get mm and mm. So the number of step, sorry, this is pitch is 5 mm per revolution. So revolution cancel and step cancel, and we get mm and mm by balancing this unit. So the number of step is equal to 100 into 50 divided by 5. This is 1000. So the position will be 1000. Next question: the atomic radius of a hypothetical phase center cubic, which radius is root 2 by 10 nm nanometer, and the atomic weight of the metal is 24.092 gram per mole, and taking Avogadro's number is to be 6.023 into 10 to the power 23 atoms per mole, and the density of the metal will be how much kg per meter cube? options are 2400, 3500, 2500, 3200. So I have to solve it. Given the radius of the atom is root 2 by 10 nanometer, and atomic weight, that means molecular weight, is given 24.092 gram per mole. So, and Avogadro's number given 6.023 into 10 to the power 23 atoms per mole. For we know for phase center cubic, A is equal to 2 root 2 times R. This is the length, unit length or axial length, which is equal to 2 root 2 R. That means 2 root 2, and R value is root 2 by 10. So solving it, 4 by 10 nanometer. So the volume will be AQ, which is equal to 4 by 10 to power Q, which is equal to 0.064 nanometer cube. Number of effective atom of FCC, we know, is denoted by Ne equal to 4. So the density will be number of effective atom into molecular mass divided by Avogadro number into volume of unit cell. So the number of effective atom is 4, and molecular weight is given 24.092 divided by Avogadro number 6.023 into 10 to the 23 into volume of given 0.064 into 10 to the minus 9 whole power 3. So solving this, we get 2500 kg per meter cube. So option C will be correct answer. Next question. A steel sample with 1.5 weight percentage carbon, no other element present, is slowly cooled from 1100 degrees centigrade to just below eutected temperature 723 degrees centigrade. A part of this iron cemented phase diagram is shown in figure. The ratio of pro-eutected cemented content to the total cemented content in microstructure that develop just below the eutected temperature is what? So this is eutected point. This line represent pro-eutected cemented. This line is pro, and this is simply pro-eutected. So we calculated mass fraction of proutectoid cementite, which is equal to mass fraction of Fe3C dash, is equal to this point and this point we have to calculate it first. So by applying tie rule, so this region we have to calculate it. So this is equal to 1.5 minus 0.8. This is 1.5 minus 0.8 divided by 6.7 minus 0.8, which is equal to 0.1186. Next we have to calculate total cementite, which is equal to this cementite region total cementite region we have to calculate it. So it is equal to 1.5 minus 0.035 divided by 6.7 minus 0.035, which is equal to 0.2197. So we have to given us given the ratio of pro-utector cementite content to total cementite. That means WFE3C dash divided by WFE3C, which is equal to 0.1186 divided by 0.2197, which is equal to 0.54. So option A is correct answer. Next question. Ignoring a small elastic region, the true stress sigma and true strain sigma epsilon variation of a material beyond yielding follow the equation sigma is equal to 400 epsilon 0.3 megapascal. The engineering ultimate tensile strength value of this material, which is equal to, we have to found. So by solving this, given true stress relation is 400 epsilon t and 0.3. We know at ultimate tensile strength epsilon t is equal to n, where 0.3 is n means strain hardening exponent. So at UTS ultimate tensile point, epsilon t is equal to strain hardening exponent. So sigma t is equal to 400 0.3 power 0.3, which is equal to 278.74 megapascal. So this is the ultimate point. We know true strain is equal to ln 1 plus strain so taking ln I left side e to the power epsilon t is equal to 1 plus epsilon, which is equal to epsilon is equal to e to the power epsilon t minus 1, which is equal to e to the power 0.3 minus 1, which is equal to 0.35, and true stress is equal to actual stress into 1 plus actual strain. So we have to found this stress is equal to true stress divided by 1 plus epsilon. This true stress is we found 278.74 divided by 1 plus this strain. True stress is 0.35. By solving this we get 206.55 megapascal. Option C is correct answer. Next question is, a cylindrical transmission shaft of length 1.5 meter and diameter 100 mm is made a linear elastic material with shear modulus 80 gigapascal while operating at 500 rpm. The angle of twist across its length is found to be 0.5 degree, and we have to find the power transmitted by the shaft at this speed in kilowatt. So given data is length is 1.5 meter and diameter given 100 mm, which is equal to 0.1 meter, and shear modulus is 80 gigapascal and rpm is 500 and theta is 0.5. So shear modulus given 80 gigapascal and number of revolutions rpm is 500 rpm and theta is 0.5 degree. We know 180 degree is pi radian, so 1 degree is equal to pi by 180 radian. So 0.5 degree is equal to 0.5 into pi by 180 radian. So the formula from twisting moment, we know T by IP is equal to G theta by L. IP is polar moment of inertia and T is torsion torque and G is shear modulus, theta is angle of twist and L is the length of shaft. So we have to found T and IP is of cylinder pi by 32 into d to the power 4 and G given and theta is also given and length is also given. So T and pi by 32 and diameter given 0.1 power 4 equal to G is 80 into 10 to the power 9 gigapascal. 80 gigapascal is 80 into 10 to the power 9 pascal, and theta given 0.5 into pi by 180 radian and a length given 0.1 and diameter length given 1.5 meter. So by solving this we get torque is 4.56 into 10 to the power 3 Newton meter. So we have to found power is equal to T omega, which is T into omega is equal to 2 pi n divided by 60. So given torque given 4.56 into 10 to the power 3 into 2 pi and n given 500 divided by 60. So after calculating we get power 238.6 kilowatt. option A is correct. Next question, consider a mixture of two ideal gases X and Y with polar masses Mx is equal to 10 kg per kilomole and My is 20 kg per kilomole respectively in a container. In total pressure in the container is 100 kilopascal and total volume of the container is 10 meter cube and the temperature of the container is 300 Kelvin. If the mass of the gas is container X is 2 kg and the mass of the gas Y, what will be the mass of the gas in container? So assuming the universal gas constant is 8314 joule per kilomole, which is equal to 8.314 kilojoule per kilomole per Kelvin inverse. So first draw the diagram. Here is the mass two gas X and Y, which Mx is given 10 kg and this molar mass My is given, and the pressure is 100 kilopascal and volume is 10 meter cube and temperature is 300 Kelvin. From gas law you know PV is equal to nRT, where P is 100, volume is 10 and N total mass, total value of gas in container we have to found, and R is equal to 8.314 and temperature is 300 Kelvin. So number of mole, that means N we have to found is 0.4. So we know number of mole is equal to number of mole in X gas plus number of mole in Y gas. So the number of mole is mass of the gas by molecular weight of the X gas plus mass of the Y divided by molecular weight of Y. So we know N is equal to total mole is equal to 0.4 and mass of the gas X given 2 kg divided by molecular weight of X gas is 10 kg per kilomole. M of the Y we have to calculate it, and molar mass is My, that means 20. So after calculating 4 by 10 minus 2 by 10 whole into 20 is equal to mass of the Y. This is 2 by 10 into 20 is equal to My. So My is equal to 4 kg. Just a minute. Next question. The velocity field of a certain two-dimensional flow is given by Bxy is equal to k bracket x I cap minus yj cap, where k is 2 second inverse. The coordinate x and y are in meter. Assume gravitational effect to be negligible. If density of the fluid is 100 kg per meter cube and pressure at the origin is 100 kilopascal and pressure at the location 2 meter and 2 meter each, what? So given velocity is equal to k into x cap y j cap. So at origin 0, 0, given k value is 2 and x is 0 and y is 0, this is 0. So given pressure at origin, that in point 1 is equal to 100 kilopascal, and we have to found at location 2 and 2. So 2 into x value 2 and y value 2. this is 4 I cap minus 4 j cap. So magnitude of velocity is equal to root over of 4 square plus 4 square is equal to root over of 32 is equal to v2 is equal to 4 root 2. So from Bernoulli equation we know at gravitational fields are negligible, so we can write p1 plus half rho v square is equal to constant. So up point 1 and 2 applying Bernoulli equation we get p1 plus half rho v1 square is equal to p2 plus half rho v2 square. So given p1 value is 100 into 10 to the power 3 plus half, and density is equal to 1000, and v1 first v1 is equal to 0 square is equal to p2 we have to calculate it plus half as density is constant 1000, and v2 given 4 root 2 square. So after calculating we get p2 plus 16,000 is equal to 1 lakh. P2 is equal to 1 lakh minus 16,000 which is equal to 84,000 which is equal to 84 kilopascal. Option C is correct answer. That's all for that is the last question, and this and all the 1 mark question from GATE 2023 previous year question. Next class we discuss 2022 1 mark question. Okay, thank you.